So now that we've visualized how Java parallel streams work for our search stream gang program, we're going to take a look at how the actual implementation works for the search with parallel streams implementation. And again, just to recap, this is the one that performs quite well relative to sequential streams, but as you can see, it's not necessarily the best way to do things. So here's what the code looks like. This is the process stream method. You can see it does a couple of things. First thing it does, it gets the list of character sequences. Each character sequence is a work of Shakespeare. So it gets that list, and then it takes the list and it converts it into a parallel stream. And under the hood, what happens is it uses the array list splitterator to create a parallel stream that will search the array list of input strings in multiple worker threads. So it's basically, slicing and dicing. The splitterator is slicing and dicing stuff, and that's what happens with parallel stream. If you look at the parallel stream method implementation, which is quite trivial to do if you're running in Android Studio or IntelliJ, you just put your mouse on there and say, go look at the source. It'll take you right to it, and you can see what it does. It basically calls a helper method called stream support.stream, passing in the splitterator and indicating it wants to make a parallel stream out of that collection. What that does under the hood is that we'll go ahead and split things up into these little chunks. Each one will be an individual string corresponding to an individual work of Shakespeare. And then those will be processed in the common fork join pool. The processing that takes place here uses the map transforming intermediate operations. The map typically does transformations that can change the values and or the types of the items that flow through it. And in this case, you can see we're just going to forward to the process input method. We'll take a look at that in a second. And that's going to go search for the different phrases that exist in Hamlet. And then the last thing we do here is we have collect, which does two things. It triggers the intermediate operation processing, namely the map part, and pulls the data from the input in parallel. And then it also will take the stream, which in this case is a stream of lists of search results, and it will create a list of lists of search results by using the toList collector factor method. So toList is a factor method that creates an array list implementation. And just without getting too far down the rabbit hole here, toList is a factor method on the collector's Java utility class, which returns a so-called non-concurrent collector that obeys the encounter order. And don't be confused by the word non-concurrent. It doesn't mean that this thing doesn't run concurrently. It means that the non-concurrent collector doesn't have to have any synchronization in it because the streams framework arranges things such that there's never race conditions as sub-results are merged together to form the final reduced list. And we'll talk more about that later. Let's now take a look at how the process input implementation works. Just like process stream, the difference between the sequential version and the parallel version is absolutely minuscule, and we'll talk about that in a second. This particular method, as you can see, takes the input sequence, which corresponds to a work of Shakespeare, and it takes that input sequence and it gets the title, which is the first line, like Hamlet, the tragedy of Denmark, or whatever. Shakespeare had a lot of tragedies, of course. So you get the title, and then we go ahead and we extract from it the text of the work. So that's the input. And then we use mphrases to find, which is a field that contains the phrases we're looking for, like all those cliches that Shakespeare liked to write so fondly. And we turn that into a parallel stream. And of course, under the hood, that uses the parallel splitterator to split things up into chunks. It uses the array list splitterator to create a parallel stream so that we can now search for the input phrases in parallel. And then we use the map method, which is the intermediate operation that does transforming. And for each phrase, we're going to search for that phrase in the input string, passing in the title, and we're also going to pass in the false keyword. And that is an indicator to the search for phrase method. We don't want to search for the phrase in the input in parallel. We're searching for each phrase in parallel, but within the input, we're not searching for a phrase in parallel. Why do I make that distinction? Because later when we come back, not today, but perhaps Wednesday or Monday, next Monday, we'll talk about an even more aggressive form of parallelization that will search for a phrase in a given input string in parallel. So we're going to go one step further and be even more aggressive in our parallelization. So right now this is false, but when we do the other version, we'll put a true in, and then it'll even be more parallel, if you can believe that. So then, as you can see, these operations are going to be run in parallel. So it'll go doing the searching and the filtering will be done in parallel with the different elements in the common fork join pool. And keep in mind that filter will be used to get rid of things that don't have search results or have an empty search result list. Or empty search result, sorry. At the end of this, we're going to collect the results into a list. So we stick it into this list of search results, which again uses the non-concurrent collector that obeys in counter order, blah, 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 blah. And then we return the list of search results here, which could be empty or not, but that's what gets returned. I typically wouldn't write code quite like this. I would probably have said return, here and done the processing this way. And so it would have been a little bit more clean. Okay, so that's the end of the Java search with parallel streams hooked method implementation. Hopefully you can see that it's pretty straightforward to do this, and we'll come back in a minute and evaluate the pros and cons of this approach.